didn't even get to cross.
Hello, so today we're going to talk about the electronic configuration. So to start off, what's an atom? An atom is the smallest particle that can have the properties of the element. The following diagram shows the layout of an atom. So to start off, we have the neutron inside the nucleus. We have the electron shells, the protons, and the nucleus, and the electrons. So the neutron and protons are inside the nucleus, and the electron shells are the orbitals around the atom.
So what is electron configuration? The electron configuration of an atom is the arrangement of electrons surrounding the nucleus of the atom in its various shells. So here's a diagram of argon, and as we can see that it has 18 protons, so it has 18 electrons. So in its first shell it's 2 electrons, in its second shell it's 8 electrons, and then in its third shell is 8 electrons as well. And this is the octet rule, as we have learned previously. And now we will see why that works. So shells are divided into subshells. The number of subshells in each shell depends on the number of orbitals within the shell. Orbitals specify the region in which the electrons have the highest chance of orbiting. The orbitals can either be labeled S, P, D, or F, each of which can contain a maximum number of electrons. So in the first shell you have an S orbital, in the second shell you have both S and P orbitals, in the third shell you have S, P, and D orbitals, and then so on. And then here we can see how much each of them can hold. So the subshell S can hold 2, P can hold 6, and so on.
Let's take aluminum, for example. Aluminum has 13 electrons and 13 protons. So let's start out with the different shells. So in the first shell there's a maximum of 2 electrons as stated before, second one 8 electrons, and the third one 8 electrons. But in this case we only have 3 electrons in the valence shell. This table right here shows the order in which you put the electrons in each orbital. So it starts out with 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and so on. And right here we see a different way of putting it, as this is electron configuration. It's 1s2, 2s2, 2p6, 3s2, and 3p1. And these electrons combine to a total of 13 electrons.
The bus-setting rule, developed by Friedrich Hunt, makes electron configuration easier to visualize. So now for an example, we choose the aluminium element from the periodic table to show it.
So as we go up the diagram, as you see here, the number of shells increases, as well as the energy level. The boxes represent the orbitals. Now let's do the electron configuration of aluminum. So to start off, we have the 1s2. As you can see, there's 2 electrons there. The 2s2 holds 2 electrons. Then the 2p holds 6 electrons. And as you can see, it goes from one box to the next box to the next box, and then it doubles up. The 3s holds 2 electrons, and the 3p holds 1 electron, as there's only 13 total electrons in aluminum. When we fill these boxes, we must first make all the boxes in each row. We must make sure that they're filled before doubling up, as you can see here. Hence the name bus-seating rule. The electrons that are doubling up will have an arrow in the opposite direction of each other.
Thank you so much for watching this video.
The information used in this video can be found in the description box below. Hope this video helped in recapping electron configuration. And a big thanks to Maggie Lewis for drawing these magnificent photos.